Welcome back. In this video, we'll be looking at two protocols that help network administrators keep their systems running. The first is ICMP, Internet Control Message Protocol. Hosts and routers use ICMP for queries and basic error reporting. ICMP operates at the network layer. The ICMP message is encapsulated in an IP packet as the IP payload, much like OSPF. It is identified by its upper layer protocol number 1 in the IP header. The specific function of the ICMP message is identified by a type and a code. There are two types of ICMP query messages: a request sent by a host or router, and a reply responding to that request. The most common request reply is the echo request reply. You are probably familiar with this as the ping command. As an aside, the developer of ping chose that word because ping works analogous to the sound that sonar makes. Later, someone created a phrase so that ping would be an acronym: Packet Internet Groper. ICMP can also be used for router advertisements and router discovery. ICMP error messages report problems. They are typically sent when a packet is discarded. These error messages are often forwarded to the application. This next slide shows the list of ICMP error codes. You probably have seen some of these errors, particularly when you have pinged a host that is shut down or unreachable. Traceroute is a network diagnostic tool that uses ICMP. Traceroute displays the route taken by packets across the network between two systems and measures any transit delays. Traceroute makes use of a field in the IP packet header called Time to Live, or TTL. We briefly talked about this last week. Recall that TTL is not measured by the number of seconds, but the number of hops. It is the maximum number of hops that a packet can travel across the internet before it is discarded. There are various implementations of the Traceroute program using UDP, ICMP, or even TCP. The Unix version of Traceroute uses UDP. The way that works is depicted on this slide. Traceroute sends a sequence of packets from the source to a destination host using the UDP protocol with an unlikely source port number. The first packet has a TTL of 1. The second packet has a TTL of 2, and so on. Each time a packet is passed to a new router, the TTL is decreased by 1. When it reaches 0, the packet is discarded, and the router returns an error message, type 11, code 0. This means the TTL time is exceeded. Along with this information is information about the router name and IP address. By sending packets in this manner, Traceroute ensures that each router in the path will discard a packet and send a response. When the source receives the router response, the source records the round-trip transit time. When Traceroute reaches the destination host, the behavior changes. This time, the host returns the ICMP message, destination port unreachable, which is type 3, code 3. Note that the Windows command is TRACERT, and it typically uses ICMP instead of UDP, unless a special command switch is used. This slide shows a traceroute from a Windows PC. Each router hop is shown with 3 different transit times, and the hop's IP address plus the hop's DNS name if it can be resolved. There are 3 transit times because 3 packets are sent each time for each hop by default. The last topic we'll discuss this week is SNMP, which stands for Simple Network Management Protocol. Complex systems require active management. It doesn't take too many devices in a network before this becomes a very complex task. Management includes monitoring, evaluating, and analyzing operation, performance, and security of the various devices in the network. The basic infrastructure for network management requires a centralized network management system that communicates with software agents on managed devices using a network management protocol. Within the device are several managed objects, such as network cards or CPUs on servers. The standard protocol for this communication is SNMP. The heart of SNMP is the SNMP Manager, which is a server configured to poll the SNMP agents for information, as well as receive alerts sent by the agents. The agents are responsible for gathering information about the managed objects and storing them in a format that can be queried, updating a database called the Management Information Base, or MIB. The MIB is a hierarchical, predefined structure that stores information about the device that can be queried or set. SNMP is an application layer protocol. Earlier versions typically use UDP for the transport protocol and use a simple shared password for authentication between the manager and agents. The latest version, version 3, includes security enhancements for authentication and encryption. Version 3 uses either UDP or TCP under TLS when digital certificate authentication is desired. In SNMP, there are two message types: request response and trap. There are 5 subtypes of requests. The first is the GET request. This is a manager to agent request to retrieve the value of a variable or list of variables. Then there's the GET next request. This request allows a manager to request the next sequential object in the agent's management information base. The third type of request is a GET bulk request. This request allows the manager to search and retrieve multiple values from an agent with a single request. Then there's the informed request. This request is sent from one manager to another when there is more than one SNMP manager in the network. Note that the latest SNMP versions allow a manager to agent informed requests for the acknowledgement of traps. There's a set request. This is sent by the manager to an agent to set a MIB value. The response message is the agent's response to a request by a manager. A trap is sent by the agent to the manager. It is an alert informing the manager that something has happened. The SNMP message includes the version number, the password, and the protocol data unit, which is the payload part of the application messages. This slide shows the format of the SNMP PDUs. The PDU type indicates the type of request reply or trap. The request ID identifies a particular SNMP request. This number is echoed back in the response from the SNMP agent, allowing the SNMP manager to match an incoming response to the appropriate request. The first part of the name-value pair is an identifier of the object monitored, such as the number of packets passing through a router's interface. And the second part is the actual value. We have covered a lot of ground this week. We talked about 2 different approaches to the control plane. We studied 2 traditional routing algorithms, link state and distance vector. We have looked at 2 internet routing protocols, OSPF and BGP. We also discussed how routers running these protocols are aggregated into regions for scalability. We delve further into software-defined networking. And finally, we briefly examined 2 protocols, ICMP and SNMP, that are used for network diagnostic and management. Next week, we will dive into layer 2, the data link layer.